I'm the supervisor for Joe Wilson's PhD dissertation. Joe is the best student whose dissertation I have had the privilege to supervise. Joe's dissertation topic is in the area of philosophy of science, more specifically on the use of computer models and computer simulations for understanding Earth's past climate, with an eye to shedding light on Earth's future climate. And the latter, of course, is very important to us in the face of anthropogenic climate change. Joe's thesis is an impressive piece of work. There's no question about it. Other philosophers have written on the use of computers, models, and simulations in future-directed climate science. Joe is really the first person to write on their use in paleo-climate science. That is to say, the study of past climate. The reason this is important is because in scientific work, paleoclimate data and simulations are actually used to inform the models of future climate. And yet this is an area that philosophers of science interested in climate science have pretty much ignored. In short, Joe is exploring new philosophical territory. Joe's thesis explores a number of issues important to both philosophers and scientists. His work is not just important to philosophers, but is of interest to scientists. These issues include the difference between an experiment and a computer simulation. So the question here is, our computer simulations are used to inform us about the future, how our climate's going to change, how radically it'll change, when it's going to radically change, the extent to which it will radically change. But these aren't experiments in the sense of experiments in the laboratory. There's something really different. And Joe is exploring that in his dissertation, and he's reaching some very interesting conclusions. Another issue that Joe's exploring is the role of paleoclimate data and model simulations in our understanding of the future of Earth's climate. Again, as mentioned earlier, it's an important issue because philosophers have not explored this at all. They've had virtually nothing to say about it, and yet scientists who are working on climate models of the future routinely use paleoclimate data about past climate, and computer models about past climate to calibrate their future-directed models. So it's really important to understand the role that this paleoclimate work is playing in our understanding of future-directed climate, how the climate's going to change. Joe's also explored in two papers currently under review by both a philosophy and a science journal, and these papers are co-authored with a graduate student in the geosciences who works actually on proxies in paleoclimate science, so it's a wonderful collaboration. They're interested in the use of climate proxies such as isotope and people are more familiar with tree rings as evidence of, say, past climate temperatures. So proxies basically are evidence in the present, indirect evidence of climate variables from the past. They allow us to reconstruct past climate. This issue, as you can imagine, of special interest to climate scientists, and it's been one that's pretty much ignored among philosophers. So Joe is really, again, exploring new territory here. The scholarly merit and originality of Joe's work on these issues is highlighted by the large number of refereed talks that he has been invited to give at highly selective philosophical and scientific venues. These venues include the Pacific Division meeting of the APA, the American Philosophical Association. It's very hard to get a paper accepted here because everybody wants to go. It's always in San Francisco or San Diego or Seattle or someplace like that. And so people are very eager to attend this meeting. There are many submissions and many rejections, but Joe's was one of the acceptances, and that's very much a feather in his cap. Another meeting he gave a talk at is a Berlin workshop on exploratory models and exploratory modeling in science. This is it was a philosophy meeting that is basically about modeling and simulation in general in the sciences. And perhaps the most impressive of the meetings to which he has attended and given a talk is the one that he gave to the American Geophysical Union, the AGU. The AGU is the biggest and it's a worldwide meeting. It was in San Francisco in December, of geoscientists. Thousands of people go to it. It's extremely difficult to get invited to give a talk there. You submit an article, most people are rejected. And as my colleagues in the geosciences say, it's almost unheard of for a graduate student in the geosciences to get to give a talk there. But Joe, a graduate student in philosophy of science, did. And he gave a talk on the use of proxies in climate science. So his work, along with this young geoscientist on the use of proxies in climate science, is viewed as that important by scientists that they would invite them to give a talk. They each gave a talk, by the way. They both had the opportunity to give separate talks at the AGU on the use of proxies in climate science. So this was really a feather in their caps, and I'm very proud of Joe. And I'm sure that these papers will be accepted and widely read by both philosophers and climate scientists. So let me just say that I can't wait to see what Joe does in the future. His work is really interesting, and it's original, and it's cutting edge, and I'm sure he'll have many new things to say about paleoclimate modeling and simulation as he continues in his career. And I'd like to close by just saying, congratulations, Dr. Wilson. You've worked hard, and you really deserve the degree that you've gotten. Good luck for the future.